He graduated from IIT Madras with a Bachelor's of Technology from Civil Engineering. His work intersects on citizen tech and technology policy in India. As a member of open source communities, he advocates for software freedoms, privacy, open knowledge, cybersecurity standards, and contributes actively to these causes. As a free software activist at Free Software Movement of India, is working on building next generation technologies to build digital commons. With this brief introduction, I welcome once again our today's resource person to hand over the session. Welcome once again, sir. Sir,
I hope I'm audible.
sir, I'll stop sharing my screen, sir. Sir, you can continue the session, sir. Sir, you can continue the session, sir.
Sorry about the issue with the mic. I hope you can hear me now. Um,
Yes, sir. Yes, sir.
and I hope my screen is also visible.
Yes, sir. Visible.
Okay, great. Thank you for having me. So I'm gonna talk a bit about what everyone's calling the fourth industrial revolution and how this is disrupting economics, how it's disrupting the world essentially, right? Like, uh, I believe some of you would be familiar with all the industrial revolutions. The first industrial revolution essentially happened uh, in the early 1800s, 18th century, when uh, we had the invention of railways. Steam engine essentially took over, and India at that time was under the British rule, and so we were never part of this industrial revolution, or rather, we were exploited at large, where a lot of cotton from India was exported to UK, where industrial mills in Manchester used to make fabric to be sold back in India, right? Like the first industrial revolution was the age of steam, where you had steam engines, steam factories, railways, and essentially mechanization of production happened. And the second industrial revolution was using electric power to create mass productions. This is the time when you had large scale dams that were built to generate power, and essentially, at some level, it was an age where you moved away from steeds to electric engines. Uh, and the third, obviously, is IT revolution and electronic manufacturing, which kind of automated production. So the fourth industrial revolution that everybody keeps referring to now is built upon the third industrial revolution, but it's called the digital revolution. It takes uh, it takes advancements in the third industrial revolutions to a next level. Uh, it's not limited to basic electronics and information engineering, but it's integrating information technology and digital technologies into your everyday life that didn't happen so much in the third industrial revolution. So some of these disruptive technologies that are taking place within this fourth industrial revolution include Internet of Things, artificial intelligence, driverless cars, smart cities, automation and robotics, electric cars with new revolutions in battery technologies, uh, evolutions in solar energy with newer solar technologies, which are integrating the solar panels into the vehicles itself. The new changes that are taking place in clean technology and recycling and renewable technologies. 3D printing, I would say, is something that has disrupted manufacturing, which is something that is powering this entire revolution. Uh, and it's, in fact, if you look at space, the space race is back because people are able to 3D print engine parts, right? Like rocket engine parts. Quantum computing is happening. It's a matter of time we get an actual computer. The theory is all set in place. People are trying actively, like companies like IBM, Google, are actively trying to get quantum computers. There's a host of advances that are taking place in every industry. Technology is disrupting. There are new materials that are coming up. There's advances in nanotechnology and biotechnology that are taking place, which are revolutionizing the way humans live. That we couldn't, which was probably the only thing you can probably call this was science fiction a decade ago. That nobody would have imagined such an industrial revolution was going to take place 10 years ago, 20 years ago. I'm going to just go further dwell into these tech. Sorry, some issue with my presentation. Give me a second. Okay, there were some images that didn't load. Let me just share it the way it is. Yeah, so this is a microprocessor called the Shakti microprocessor, which was made by IIT Madras's computer science department. And let me try this back if it loads now. Okay, the Shakti microprocessor is an indigenous microprocessor. Sorry, the images are not loading. It was made based on this open source technology called RISC-V. So RISC-V is an open source instruction set. When you talk about microprocessors, you have the Intel microprocessors and the ARM microprocessors, right? They all have their own proprietary architectures. But RISC-V is an open source architecture. What that essentially means is that anybody can use this architecture to make their own microprocessors. And that's what IIT Madras did here. They made an open source microprocessor called the Shakti microprocessor. And the technology is open. Anybody can technically, with the manufacturing capacity, can start manufacturing these. And I believe there are companies like Tata which are just getting into manufacturing microchips. There is a huge shortage of microchips in the world right now. I don't know how many of you noticed this, but because of the COVID-19 lockdown and the pandemic, the economy went digital. Everybody started buying more laptops, might buy more digital devices. There has been a huge shortage of microprocessors. And because of this shortage, several other industries which use them have stopped production. And it's impacted even manufacturing in cars because your cars need microprocessors, right? So end of the day, a shortage in chips has essentially blocked down global economy. And everyone's now trying to see what they can do. Every other country is now trying to see if they can start setting up microprocessor manufacturing facilities. India, at some level, was planning to do this for decades now, and I think this is the time where we are trying to do this. So this processor is really important for powering the Internet of Things. If you're trying to build anything new, you need a microprocessor. Everything from Internet of Things to artificial intelligence runs on top of chips, and you need these microprocessors, and India doesn't have them. We always import them. There are few global manufacturers, and most of them are situated in Taiwan or South Korea. This is an opportunity where there is a huge potential for Indian entrepreneurs to essentially start manufacturing these microprocessors and at the same time provide software on top of these architectures, right? Like what happens is when I believe some of you already have done this. When you write your operating systems, when you design your programs, you design it based on your microprocessor, right? So you design it to your Intel architectures or your ARM architectures. So RISC-V architecture is the new architecture where there is a need for huge human resources and manufacturing requirements uh, in the global microchip supply chain industry. And all of this is powered by open source architecture because it's publicly available. Anybody can use it. There is no proprietary patents on this, unlike Intel or ARM, where these there are intellectual property rights by the companies that own these processors. So let's go to the next sector, robotics and automation. I think the most important part of this fourth industrial revolution is that automation is bound to happen. It's already in place. I don't know if some of you know, a lot of your cars are already manufactured autonomously to a large extent by these hand robots. In the image here, you can see a arm robot placing a brick. So there are robots which the companies who are trying to develop robots which can essentially build, right? Like you don't need a human to do this job anymore. Robots can pretty much imitate humans, and they can uh, build everything from a house to manufacture a car to pretty much anything can be done by them. And well, the only question is how efficiently can they do it. Humans even now can by far to a large extent can be more efficient than robots, but robots are catching up from what it is to be believed. A bricklaying robot right now is 5 times efficient than a human. It can go as up as 20 or 100 times in future. And this is the efficiency that matters because automation of construction is not something new. It was proposed as back as early 1900s. There were patents which were issued for bricklaying mechanisms as old as 1902, 1904. But it's only now that there is adoption, and especially with the pandemic, what happened is there wasn't much access for labor, right? Like people were stuck in their houses. They couldn't come out. They couldn't meet. They couldn't be at their workplaces. So this drove up the need for robots and automated systems in every sector, especially in construction because they couldn't stop construction of large projects. It would essentially delay things for the entire economy. So everything from warehouse automation, if you look at your delivery automations that takes place in your Amazon or Flipkart, most of their warehouses are automated. The moment you order something on Amazon, it's actually a robot which processes that someone has ordered this particular product. It goes and fetches that particular device or your order from the warehouse, and it then goes through all of the post processing. Right, most of this supply chain is automated at their warehouses. Amazon has been trying to automate a large part of its delivery too. There's a push to kind of automate delivery through drones, through small robots, I would say, like driving robots, which are not like big time cars, but small, tiny robots which can go on sidewalks and which can do it. Though these plans are really early because some of what Amazon tried to do in UK kind of shut down, but this is a future that they are anticipating for. Within India, several companies like Swiggy, Zomato have actively applied for Ministry of Civil Aviation's permissions to start experimenting on drone delivery for food, right? So automation is taking place, whether we accept it or not. It's going to impact every industry. It's just not cars that you might be widely aware of that's happening in the US. It's happening everywhere else. In fact, there are automated ships that are going to be transporting all of your global goods from now on. Manufacturing as such is largely being automated. Your kitchens are being automated. There are robots which can make food. So the most important feature, I would say, of this industrialization era, the fourth industrial revolution, is robots and automation. And all of this, of course, is powered by AI. Uh, I'm not going too much into that. So let's go a bit into 3D printing. Uh, I think 3D printing, it existed for a really long time, except the patents over it expired just 10 years ago or so. And we started seeing a lot of adoption of small scale prototyping 3D printers that kind of came out from something called MakerBot, Ultimakers. A lot of these companies started making 3D printers. I believe some of you would have at least seen it or have heard of it, or you probably have one at your college. But those printers are really small, tiny prototyping printers. What we are witnessing in the entire 3D printing manufacturing industry is that there are these large-scale robotic 3D printers which are doing metal 3D printing. This is a part of a rocket that's being 3D printed by robots, and actually there are companies like SpaceX or Blue Origin or even at NASA, there's a huge usage of metal-based 3D printing processes to start building these large parts, large rocket parts. And it's not limited to manufacturing in the traditional senses, but day-to-day construction industry, for example, there's a huge potential for 3D printers, large-scale 3D printers, to print large parts or houses or even parts of your highways, parts of large-scale projects, right? Like 3D printers can build complex shapes. So if you're thinking of building something new and innovative that nobody has built, but it's very complex, the technology now exists to actually print it. And it's not that these technologies are only in the West. In fact, I believe a few months ago, there was a company from IIT Madras which actually built a 3D printed house. And there was one more startup from IIT Madras which was using 3D printers to manufacture rocket engines. So 3D printing at large has revolutionized manufacturing, and with robots taking care of most of this, people are trying to build all sorts of things and they're trying to automate. So your robots are essentially driving this fourth industrial revolution. And as I was talking about space, let's go look into what's happening in space. Because it's robots that are making these systems, there's not much of need for human intervention. We're also witnessing technologies like the reusable rockets by SpaceX and Blue Origin. At the same time, what has essentially happened is access to these technologies have kind of became easier. There are open source organizations like Libre Space Foundation, which are building open source satellites, which are building open source technologies to power a space race. It's just not companies like SpaceX and Blue Origin, but you'll find a lot of technologies that NASA has developed over the years on their websites and their GitHub pages. You'll find components like the recent Mars rover, I believe, part of their entire code of and also the plans for the Mars rover were public on NASA's GitHub pages. So access to these technologies are no more proprietary. They're not limited to companies like SpaceX or Blue Origin. They're available to anyone. In fact, there's a huge rise of this student universities projects where students are sending these student satellites into space. I believe ISRO has already done quite a few of satellite launches for student projects. This is something that's open for you all, and there are enough open source satellite technologies out there for you to experiment. In fact, you can potentially 3D print your own satellite, from communication satellites to earth sensing satellites, which we would need to understand what's happening with climate change on the planet. anything can be launched and as quickly as possible because there is a huge revolution in the sector that's already taking place because of all these disruptive technologies. Okay, so let's come back to the whole issue. Life on planet Earth is changing. People are going to go to space. Probably in our lifetime, there will be a human on Mars. And but at the same time, what's happening to the planet is that all of these technologies, all of this industrial revolutions, from the steam age, from the first industrial age, have essentially messed up with the planet. The planet is warming up faster. Several species are going extinct. Essentially, the planet's in a very bad shape. And the only way to stop doing all of this is to move into cleaner technologies, to start reducing your impact on polluting industries, right? So we have to move away from thermal coal plants. We have to move away from uh, petrol or diesel-led cars, which generate pollution. So that there are a host of these technologies that are available right now, which can make this possible, which can ensure that the planet's temperature does not rise more than what it's already. And if you were following news, I believe a week ago there was a report from IPCC. From the UN, from the United Nations, which actually said this is a final warning for us. We can ensure that the planet stays as is and doesn't go. It doesn't need to go as bad than it already is, right? So if you look at some of these technologies that are taking place, people have realized because of the changes in climate, farming outside is going to be complex. There are whole greenhouse automated farming that's taking place. People are going vertical farming uh, inside large greenhouses where robots are essentially growing vegetables, plucking them. It's all automated. Uh, there is a huge push for people to start adopting solar energy, renewable energy. There's going to be a huge push uh, for recycling of water and waste. Anything and everything will be available for people to shift away to cleaner technologies. Now, while there is a push to do all of this, while the technology also exists to do this, it's not easy. It's not happening, right? Like, sure, solar is a very age-old technology. It dates back to 30, 40 years. Uh, but why is there no adoption of it? Because the cost of manufacturing was high. It's drastically decreasing now. There are revolutions in battery technologies that are making it happen now. But even then, even with all of this, most of this technology is not in the public domain. It's not accessible for every common man. The only way we can ensure that everybody essentially gets access to a lot of this technology is if it's in the commons, that if everybody has access to it. Uh, 3D printing got revolutionized because the patents over it expired, and there was a huge push by the maker community, which essentially built all sorts of things, and they put all of their digital models in the public, right? Like they use licenses like Creative Commons to essentially share all of this. Several of the thinkers and makers started making their robot projects files in the public. I mean, you would be already aware, as I was saying, some of the projects from NASA are in the public. So if we really want to essentially adapt, everyone to adapt into this fourth industrial revolution, the only way to allow that to happen is to take technology to everyone. And you don't need to reinvent this wheel. You don't need to invent new technologies. What you need to do is see what technologies are already out there, and quite a lot of them are already out in the open. All you have to do is adopt them. All you have to do is promote them among every other people. Like for farmers, if you take the case of farmers, the new farm bills have essentially privatized farming. Uh, Whatever the reason it was, but farming essentially is getting disrupted, and farmers need access to technology. And these people can't afford to buy large scale robots that some giant American giant can actually build. What they need is something cheap, something made indigenous, something that they can use in their farm. And there are a host of these technologies already available in open source, with some of which you can build. And any industry that I have mentioned right now, everything from space, 3D printing, and robotics and automation, it's already happening in India. Also in Hyderabad, the Telangana government is actively trying to build an ecosystem of hardware manufacturing. I think there is a push to build something called the Hardware Park, and there is also a push to build something called T-Works, which is a prototyping hackerspace kind of setup, makerspace kind of setup, where you'll have access to all sorts of machines from CNC, computer numerical control machines, to laser cutters, to pretty much everything to start prototyping any new technologies that you may want to build. Uh, and the beauty about all of this is, because a lot of this is already in the public domain, you can pretty much download a model from the internet and 3D print it. You can print your own robots. There are quite a few open source robot projects. In fact, there are efforts to start making open source driverless cars as well, right? I believe some of these projects may be of interest to you, and I think you may want to pursue some of this to build your own businesses. The most important takeaway that I have you for there is that when you're trying to build any business, what you need to look for is what kind of value that you're trying to generate. If a lot of these technologies are already available, uh, if but there is no adoption for it, the reason is the economics. Because it's costly, because not everybody understands it, access is hard, there are regulations, some of which are being taken away now. So there are a host of factors that can lead to a technology's adoption or rejection. And if you're trying to essentially make money, you're trying to essentially start a business on top of it, uh, the technology is available. The technology will not be a challenge, but rather it would be the economics and your business model. Uh, you need to essentially look how can you adapt to this industrial age? How can you adapt to the business models in this industrial age? Everybody wants to build a platform, but it's not so easy to build platforms that can compete with the already existing ones. So if you're trying to participate in the larger economy, then look forward for places where some of these technologies have not reached out to, right? Like farmers, for example, agriculture, agri-tech is one that space. Health is another space that's upcoming with the pandemic. There is a huge requirement for health. You have all witnessed it that in, in the recent past, we didn't have enough oxygen in the country. We didn't have enough hospital beds. There was a host of challenges that the country faced while facing COVID. The only way to solve this is uh, potentially making all of these technologies and making it available to anybody to use. And during the pandemic actually, there were some Indians, some hackers who essentially built an open source oxygen maker. I think the organization which built that was called Maker Asylum. You can look it up. They used an existing open source model and tried to build it from local parts. So everything, pretty much everything that you need in your life can be built by you. The technology is available in the commons for anybody to build pretty much anything. I hope you explore some of these technologies. And as someone who is part of the free software movement of India, what I can tell you is that the free and open source software movement's philosophy, the free is not about that it's free as in free chocolates, but it's free as in freedom. Uh, you have the freedom to access these technologies and modify them. There are no licenses, there are no patents, there are no intellectual property. But there is a cost to manufacturing this. There is a cost to build a 3D printer. There's a cost to build a rocket. There's a cost to all of this. You need to figure out your economics. Until you figure out all of that, these technologies, while disruptive, you cannot start anything innovative to make a mark, to potentially start a business that's disruptive in nature. So I'll end it there. I hope I can take some of your questions. If anybody has anything for me, I'll just stop sharing my screen.
Sir, can you please guide our students in how to start like a new product design and all, how to continue with the development part?
I mean, see, there is no one way to do. There's no one right way to do it. Uh, as I was saying, so a lot of these technologies are already in the public domain. All you have to do is go find out, figure out the problem, figure out the sector that you're trying to solve it, and check if it was already attempted by someone else. If it was already solved and if the technology is already available, then you really need to look into uh, uh, its adoption and see if you can build some of it in a different way. Uh, Take space right now. Telangana, Hyderabad wants to become a major player in space manufacturing. Uh, it's a mission for Telangana government. Now, when you're talking about space, the big company that comes to everybody's mind is SpaceX. While SpaceX has essentially solved all the problems around rockets, reusable rockets, and all of it, they still face a lot of challenges. But they're a very American company, and India essentially wants its own space sector. So there are a lot of problems within that sector which are relevant for India. There's a need to build reusable rockets, for example, for India. There's a need. So if you have to do them, how would you go about it? The only way to do is you figure out whether how do you prototype it, how can you reach it, see what sort of technologies that you need to do it, how do you manufacture it. You will need 3D metal printing. So it's not that all of it can be done by you in your academic environment. You would need to access specialized research ecosystems to do this. Some of them do exist in IITs. See if you can collaborate with them. See if there are other maker spaces and innovation centers in your city, right? Like if you're trying to make a small IoT project, a lot of the components are easily available for you to do it yourself. But from doing a prototype to taking it to the manufacturing to be sold to the consumer sector, there's a host of things that needs to go through it. The first thing that you can do as a student would be to prototype something within your college environment. And once you have those prototypes, then you can go reach out to a host of these people to see what you can do to take it to the market, to essentially start a company and to sell it. But that's stage two. Stage one is essentially you building something that works and that solves a problem. Unless that is there, you can't go to stage two of manufacturing it and selling it. Do not look for a solution and then find the problem, because there are a lot of solutions which are already out there, which have already solved these problems. If you're trying to attempt something new, see if there is a problem for someone. whether it could be a farmer, whether it could be a business, whether it could be anyone that you know. And if there is a problem that they are saying that exists and you need to help them solve it, see if there is a solution then. And if there is a solution, provide the solution. If there is no other solution, make it. So, so there is no direct answer to the question how to do this. It's just that you have to keep iterating this so long so you solve that problem. Identify problems, see if there is something that you can add of value to this, see what are the sectors that are being disrupted. A lot of these problems are already being solved. It may so happen that what you're trying to solve is something already solved. So do not try to reinvent this wheel. Nobody is going to come to you to buy something that's already available for a consumer in the market with a brand. So building brands and building businesses is a whole new thing that you need to learn. You need to learn in terms of managing a business. I'm not going too much into that because that's something I believe that comes after you build your product, after you build a prototype. So look for problems, try to understand how different industries and ecosystems work. How does the space industry work, or how does the agri-technologies, agriculture industry works? How does farming happen? So where are the problems? In case of agriculture right now, I've listed a few for you. For example, farmers need newer technologies to increase their yield output. So there are people who are trying to build robots which can pretty much automate it. So see what industries need automation, and even when you automate something, even if you build a technology, because if the economics don't work out, if you're trying to supply a robot that costs 1 crore to a human who can do that job for 1,000 rupees or 2,000, companies may not be interested to invest 1 crore in building that robot. So even if your technology is great and even if your technology has solved a problem, without the right economics, it will not work out. So some of the tips that I can give you to start exploring this is start exploring some of these open source technologies, check out their documentations, check out what's happening with this whole RISC-V architectures, for example. Learn 3D printing. I would say skill yourself. Once you're skilled engineers, as an engineer, you can solve pretty much any other problem that's out there. You don't have to go look for a problem. You will understand what the problem is once you skill yourself. So the first step is to essentially start skilling yourself, start understanding how different ecosystems work, then start identifying problems and try to solve them. See if you can find like-minded friends or like-minded people in different ecosystems and partner with them to build something. You can always approach us. We are in Gachibowli. We are working on some of these technologies. We are also trying to set up our own tiny community of thinkers who can look into attempt to solve some of these problems. We are trying to identify problems where we can intervene, where we can make open source technologies. Our primary aim is to essentially ensure that we build technology and keep it in the commons. We're not really interested in the business aspects of things, but that's something that you may be interested and you're happy and you should be pursuing. There are ecosystems in the city. You can go to, once you have a prototype, you can go to a business ecosystem or a startup ecosystem like T-Hub or any of other venture capital ecosystems to access money, access capital to start manufacturing your prototypes into products. But this is a long process. You will figure it out as and when you make these systems. It's not something that I can tell you in a 1 hour session. But what I really wanted to introduce you was the disruptions in technologies that are happening and where you can potentially learn or reskill yourself to attempt. Like, yeah. Okay. Any more questions? Again, I'm happy to answer.
Students, any more questions? Sir, I have a question on behalf of students.
Yeah.
As they are still students, not even graduated, if at all, if you have any prototype idea, what are all the challenges that could be faced by the students, and any suggestions regarding this?
Okay. As someone who went through this back in IIT, uh, there are a host of problems that you can encounter making building a student project, right? Uh, I found discussing these with your fellow students and as well as your professors quite helpful. But apart from that, there are active online communities, right? Like that's how I got into a lot of these open source communities. I was building open source. Sorry, my student project was kind of on smart cities. It was related to smart cities, and I was using a lot of mapping related technologies, and a lot of these were proprietary, right? Like something that those were inaccessible for students unless you can pay. So, so I was using a lot of open source technologies which are freely available, and there were a host of these communities around mapping. For example, in India, there's a community, there's an open source project around maps called Openstreetmap, which is an alternative to Google Maps. All of the data around it is public. You can use it to build your own technologies. You can use it to build your own map. Like you can make a map of your college. If it's already not there, you can add details to it. So, so find these communities, see if they can help you with some of the problems that you have. There are a host of them. Like there are robotics communities that are popping up in India. There are AI groups. There are people who used to meet up pre-pandemic to discuss some of these technologies. Uh, that's not happening physically now, but there, they are still doing it virtually. The people who are like you will have groups which are discussing specific technologies, all sorts of technologies. The people who would be discussing about programming languages, people who are looking at IoT in particular, people who are looking at artificial intelligence. Uh, I'm not sure if there are any particular groups around 3D printing much in Hyderabad. We are a group in that sense, but there are active groups and active makerspaces in Bangalore and Delhi. So try to reach out to these groups which exist, try to learn from them. There's a lot of documentation that's available. For example, space. If you really want to get into that, check out the work that the Libre Space Foundation does, right? Like they are trying to build an open source component for everything that is required in the space sector. You can learn from what they already have done because a lot of knowledge around this is already in the commons. So, which is why I'm saying if there is no community, like I would say there is no active space community in Hyderabad, but it's going to come. It's going to happen soon. If you want to enter that sector, go read all the information that NASA, the European Space Agency, publishes. Right. So, yeah. So it could be a hobby project, it could be a student project, or it could be even a large student project like a student satellite. There is enough information that's available. There are enough ecosystems that are available for you to reach out. Find a mentor after you have worked out all of this. Mentors usually help you because they can connect you to these ecosystems if you don't know who they are and where they exist. Uh, yeah, so this is a process that everybody has to go through. It's not new. but at the same time, it could be challenging for students, and especially, I'm not sure if your classes have started. I'm hoping all of this goes away, and when you go back physically to your college, you can see if you can start working on this some of these prototypes in your own college, or visit some of these other maker spaces.
Students, anything else would you like to ask? You can. So if nothing, have shared a feedback link in a chat box. All are requested to fill the feedback form. And before closing the session, Sir Srinivas Kodali, sir, I would like to thank you for sparing your valuable time with us, for sharing your knowledge on robotics animation, 3D printing, and how to how to go with our startups with real life problems and all. Thanks for sharing your views in this. Regard to our students. On behalf of our management principal and HOD, I once again thank all the participants and Srinivas sir for their valuable time. So thank you, sir.
Thank you for having me, and I'm always happy to come back. And I request any of you who are interested to work, or who are looking forward to pursue some of these technologies, to always reach out to us. We would be happy to help you with some of these projects if there is an interest.
Okay, sir. Thank you. I'm closing the session, sir. Thank you very much once again. Participants, before leaving the session, all of you have to fill the feedback form. Uh, Thank you all.